Hello Internet! Today we are going to be looking at making tests in Unity. Specifically, we're going to be looking at how to test this new health tracking object that we've created. And so Unity has recently added a test runner into it, which uses NUnit tests in order to test your Unity stuff. And there's a number of ways you can test things. And at its core, really, all you're doing is just doing basic NUnit tests like you do in every other thing. And so this gives you a way to do that in Unity. You can kind of see over on the left here, I have already created some tests. I actually have a play mode and edit mode tests. Those are slightly different. Play mode will actually start your game, and it will attempt to run the tests that way. Edit mode will run them in the editor. And so you can either simulate frames by using coroutines, or you can just assert that a certain value is true. For us, I think for this, we can stick to edit mode testing and do that. And so the general idea is your test will look something like this. This is pretty much the default that Unity will give you when you create a test. I've added this assertion, which is going to say assert that 1.0 is equal to 2.0. And so the way these tests read is the left-hand side is what you're expecting, and the right-hand side is what the actual value is. So if we were actually testing this, we would be saying 1.0 should be equal to our health, for example. If we were testing the health, that would be how this test would read. It's in my mind, I always read that backwards and then kind of have to manually flip it, but that's just me. And so the way this works is these assertions are evaluated and then returned in Unity's editor. And we can actually see what's going on here. This is probably small on that screen, but it will give you a readout of how long the test took when you select it, where the test is. So this is the edit mode sample test simple passes. That's just the name of the function. And then we expected 1.0D, which a decimal, or a double, sorry, and we got 2.0 double, and just say it's a double type. And so that is our error for our failed test. And we can use this to kind of compare and contrast and see what is actually happening, what's causing this to fail. So before we get into writing this, I'm going to talk a little bit about why we're writing tests, because it's something that I feel like a lot of people kind of get into the habit of, we're going to write tests, so we're going to do like test-driven development, and everything's going to be under test and things like that. In my opinion, that doesn't always make sense. Tests aren't your product, whether you're making a website or you're making a game or you're making an app. Nobody should really care if there's tests. The reason you have tests is so that you can validate your software. And so what we're trying to do here is to create something that makes it comfortable for me to say that my health checker is working without me having to test manually every one of those use cases, so that I don't have to spend that extra time going through each of those cases to make sure that it's actually doing what I think it's doing. And so part of the trick of testing is figuring out what those cases are so that we can validate that this is actually what we want. And so that's sort of why we test. It's not just a way to cover everything, get 100% test coverage, find every function, find every use case, and cover all of that. You can do that and it will work, but a lot of the time that's going to create a lot of extra work. And it isn't always worth it. Tests can be kind of heavy as well, because we're effectively going to be writing probably almost twice as much code here as we have for our actual script. And when we change our health object, if we ever need to do that, we're going to need to maintain this code as well, which is effectively meaning we're maintaining 3 times as much code. And so we need to get more value out of that. If we're not, there was no point in this. So that's just hopefully a quick philosophy on testing. There's a lot of ways to do it. There's a lot of different types of tests. A lot of what we're going to be doing here is unit testing. where you try to identify a specific unit of what your object does and test that specific portion. So if you're looking at like a building, you're not testing the building, you're testing, does the door open? And so that's sort of what we're going to be doing. We're testing a health script, and so things that we're going to be caring about are going to be like, can we change how much health this object has? Or when we change the health, does something fire? One other useful thing, we're using these tests as a way to validate. And so that should drive the design of your tests. What I mean by that is you don't want to write a single test that is going to test every part of your object. If you do that, you'll know if your object is working or not working, but you won't, if it fails, you won't know what isn't working. And one of the really handy things for tests is they can point you to problem areas that you may not know about. And so when things start going bad, it's probably not the whole thing that's bad. It's probably just either one function, maybe a misspelling, or a random value that is not what you think it should be. And you want to be able to find that part without all the other stuff. And so tests make it really easy to do that if they're written in a way that makes some sense. And so that's, I guess, a quick testing philosophy. We might get into more of it as it goes on. It's a really complicated topic, and I definitely am not an expert, but that's at least what I can offer. So what I'm going to do to kind of style this is I'm going to copy from our scripts folder, which is where our scripts live. I'm going to copy everything below that inside of each of these. I have two folders. I have a test folder, and then inside of that I have an edit and play folder for edit-based tests and play-based tests. And then we can use each of those. In order to create these, you just right-click and do create. It might not exist anymore. Testing and a test assembly folder. And that will create you a testing folder with some configuration here. Unity has some configuration about what is exactly being tested. Because there's all these different platforms that Unity supports, your tests may only work on a certain number of them. You may have Android-specific features or iOS-specific features or VR-specific features that you only want to test in those cases. And so that's how this works. I don't know too much about this, so most of what I'm doing is just editor-based stuff. I'm focusing almost primarily on unit-based tests, which are going to be focusing on like strictly code and not relying on Unity's lifecycle or anything. Part of the reason we designed our health object the way we did is because it should be easy to test in this fashion and won't rely on a lot of the Unity stuff that we might otherwise need. So that, I guess, is a little bit more on that. We are going to create a testing script. So C# test script, let's call it R. It would be really handy if I knew the name of what I was gonna... The health modifier, is that what we called it? No, the health tracking component. So we are going to call this our health tracking component test. So delete that. Not a C# script. I'm getting totally in the wrong thing. Let's do testing, C# test script, health tracking component test. And so that is going to generate our tests, and we actually can already see that they've popped up over here. They're just a gray circle right now because we haven't run any of them, so we don't have any status or anything like that. But we get two default methods. I'm going to delete the second one. So this one right here is actually using a coroutine to test multiple frames. I don't really care about that right now, so we're gonna get rid of that and skip it. And I'm not entirely sure how that works in edit mode anyway. I think that's mostly for play mode, but it doesn't matter anyway because this is what we care about. The way this works, there is this defined test, that's your function, and then it's just like a normal C# script. You do your script and it returns something. the name of it is going to be what shows up in your inspector in Unity. So the test runner is going to say this name. And so that's sort of a part of what we're testing. The object we're testing is this health tracking component, which looks like this. And so that has a health property that is exposed and will change whenever the value that is provided to it is different. And so there's a few different things we want to test. We want to test that, I'll just point them out. We want to test that when the health is different, that it changes. That's the only thing we're going to test in that method. The next thing we're going to test is that when the health changes, it should also fire off an event. Those are two separate tests. And the reason we're separating those is because they're two different actions that are being triggered by this single thing. And that way, if one of them fails, we know why that test is failing. We know either the event is not firing or our health is not being modified. One of those two things is happening. And so it gives us some action that we can actually take to fix it. Otherwise, if we just said setting the health is not working, that actually really isn't that helpful, and it means that we have to go and debug it and spend more time to try to figure out what's going on. And I don't want to do that. So we're going to avoid that as much as we can. So that is the goal. We're going to start just with this, and we'll get into some of the other stuff. I think that should be good. Another thing we're going to want to make sure we do, we have this null check to make sure if it is null after starting, that it isn't null afterwards. We probably want to make sure that that's actually happening, because otherwise we'll get null pointers and our events won't work, especially because we're relying on that in many cases. So there's some of that stuff that we're going to want to check as well. So it seems like we have three things that we really care about: that the health changes, that events fire, and that the event tracker, the event system, is initialized. And so that's the three things that I'm going to focus on in this. So let's do I really need all of this? I don't really want all of this. Let's do setting health changes health value. I always suck at naming things, so we're going to just kind of pretend like this. And every framework kind of has its own little thing. A lot of like the testing stuff that I've worked with has been in Java and using Groovy, which has a very different syntax. You should watch my Spock videos if you're interested in that, because it's very different. But we're going to go with this and try to make it work. So the general idea is we need an object, so we're just going to create an object. I think that should work. So we're going to do a health tracking component. Our component equals a new health tracking component. And I think we can just initialize these, but we might not be able to. Also, we're in the wrong namespace. Huh. That's fun. So we're in the test namespace, and this isn't in a namespace. We cannot be found. So if I remove this, that error should go away, except it doesn't. Use implicit type. Okay. What? Health tracking component does not exist. Could not be found. I have completely overlooked something. So first we're going to put that namespace back. Next I'm going to go and look at Unity's documentation on how to do this, because I thought you could just do that. But you can't just do that because it doesn't like that. So that's about as much useful information as I have. So we're gonna skip that, and I'm gonna go find the documentation. So be right back. Okay, we're back, and it's the next day, because I got very confused and went down a massive rabbit hole and didn't actually solve anything. So I've talked with some people, And I think I know what the problem is. I haven't tried it, haven't tested it, but we're going to figure out. So the problem we're running into is each of these testing repositories, I've rearranged the folders a little bit. There's just an editor-based test now. All the play mode tests I deleted because it was just extra complicated. But the way this works, what's actually happening here is if we open this and I scroll up a little bit, you can see there's two CS project files here. The first one is assembly c#.csproj. That is going to be like our main assembly. That's going to have like our game assets and stuff in it, all of our normal scripts. The next one is tests.csproj. That's the one for the tests. And so what seems to be happening, we are in the test project, the test assembly, and there's no link between those two dependencies. And so we need to define some sort of package, and then we can theoretically link them. So in here, there is assembly definition references. If I do a plus here, we actually do get a number of options, but we don't get that assemblies. We don't get that main assembly. But there is this tests.asm.def that I think we can use. So if I copy this file and put it in the Asteroids VR folder, let's actually put it in scripts. Yeah. And we'll call this Asteroids scripts. Optional Unity references. I don't think we need any of those. I can just keep this empty, I think. Maybe. I don't know what I'm doing. We're gonna find out. I'm probably gonna have to recheck some of these include platforms, but I might not actually, because I think this assembly will only end up being used when we're actually testing the thing. All I'm trying to do here is create a file that defines an assembly for Unity to generate so that we can include it in our tests so that we can test it. Also, I think I've uncovered that I'm not actually supposed to do things this way. And so we're going to keep going and get this working. And we might decide that this is way too much overhead and we want to go a different route, maybe import some other testing package to do this. It gets a little bit complicated because we're using MonoBehaviors, and MonoBehaviors don't like to be instantiated. And so when you try to create a MonoBehavior, Unity gets mad. And if you try to create them in some other package, that package also gets mad. And so we kind of need to work with that. But we're gonna see what happens. So we're gonna call this Asteroid Scripts just to match the name that we gave it up here. Save this. And now that file should exist in Unity when I reload it, theoretically. I don't know if that's actually going to trigger anything. I don't know what it actually does. But we can see it here. So if I include that as an assembly definition reference, theoretically, that means that it now exists in our project. What we can also do is go into here, unapplied import settings for tests, apply those. So that should regenerate that package, theoretically. And this appears to have all the same or references. It doesn't have test assemblies. It's only used in tests and not in player builds. Predefined assemblies won't reference this assembly. I don't think we want that enabled because that will make it only show up in tests. This is for our actual game scripts. I don't know if they can overlap or not. We're going to pretend like they can. They can't. So we'll just leave it like it is. Honestly, most of the goal here is to get unstuck, and then we can go in and get ourselves stuck again once we get past that. Okay, so I can F12, which means go to definition, which means at least at the Visual Studio Code level, things seem to be working. So we also have this new Asteroid Scripts CS project file. None of this matters really to you. You don't need to worry about it. All you need to know is if you go into tests, that's underneath my camera, but if you go into the test CS project file, you should be able to find the asteroids scripts reference. And that will be including that project file in this project, which means we can actually use those references. That's what we just accomplished there. And so now, hopefully, we can write our test and actually get it to work. So we're going to do like the old-fashioned way. There is actually a MonoBehavior test option that Unity provides. I don't really know the difference between that. I'm going to try just creating a new game object, add the component, and then do var or do health.health equals some value. Let's say 100. And so we're going to set the health equal to 100, and then we are going to assert r equal health.health and 100. But we want to reverse these because the expected and then the actual value we got. And so if we do this, theoretically, we're going to create a new game object, add our new health tracking component to it, and then set that health to 100 and assert that it is 100. And that should be everything we need to do. This test works for this right now because we don't have any default values. If I were to say this is equal to 100, suddenly our test doesn't work anymore. And that's kind of not great. Ideally, we would do some data-driven stuff to actually get multiple different values of health in there. I'm not going to do that right now because that's just making it more complicated, and we don't even have a running test. So let's do that first and get this test running, get the other two test cases covered, and then we can move on and explore better ways to do this after we have it working and kind of iterate on the design instead of trying to get it perfect the first time. So here's what we have. Should set our health and test it. So theoretically, big theory here, I should be able to clear that. Typer namespace world of 0 doesn't exist. I tried to add a namespace as part of the iteration of this whole testing thing. That didn't work. Well, it did work, but we didn't have a reference, so it didn't work. Long story. But we can take that out. We don't need it. So that should get rid of those two, and it looks like we have one more. No. Which means, why doesn't that clear? That's kind of weird. Line 4. Okay, I think it's just kind of broken. So let's try it. Can't start it because we have compilers, but we don't have compilers because of hold on. I think we can try re-importing. That doesn't make sense. I don't think I want to do this. Let's try it. That should relaunch Unity and hopefully get everything fixed. That's kind of the nuclear option, as far as I understand, but so we'll try that, hopefully get everything working. Once we get that test working, that will prove at least that we've tested the setting of our health. Long story to get testing of setting a value. But once we get that, everything else should go a lot faster because we should be able to test like the events and test that things are firing and that we can actually get the stuff out. Those were the three that we wanted, right? No, we wanted to test the start, the health value, and then the event firing. So right now we're doing this part. The next thing we want is to do the fire on health change. And then the third part is going to be actually doing the start thing. And so we can actually manually invoke start because just by attaching the object to the game object, we don't actually fire the start method. That won't actually trigger. Start is defined as happening immediately before the first update of an object. And these objects are never going to be updated because we're in edit mode. We're not doing anything. Did I crash Unity? I was kind of expecting it to come back. All right. It seems to have completely abandoned us. So let's give this a... Looks like the project is already open. Oh no. Well, I re-imported a little bit too much. I'll figure this out, and when we get back, we'll have Unity up and running, and we can move forward, hopefully. So I'll see you then. Task manager, you go away. Oh, good, no tasks. Unity Hub. Hey, there it is. Okay, I think we're in a good spot. We don't have any errors anymore. Just re-importing worked. It was actually working. It just took longer than I expected, and there was no dialogue. So tried to open it. It didn't actually need to do anything. It was just starting. So we should be able to run these and get a result, and it fails. Null reference exception. That's fun. Object reference not set to an instance of an object, because we have not initialized our thing with the start method. So what's ending up happening, I'm assuming, is we're trying to hit this fire on health change, hitting that, and it's not working. So we are actually going to do on health change is not null. Can we shorten this? So there's a null termination operator in, I don't know if that's the right name, in C#. And what this does is if the left-hand side is null, it doesn't do the right-hand side. So the operator is the question mark period. And so you can use this to kind of chain things if they might be null. And the idea is left-hand side is null, don't do the right side. So in this case, if we don't have a event set up, don't try to invoke the event, because it's just going to throw a null pointer. So that should actually fix that error. And then we just need to make sure that our tests are good, because otherwise we're not going to get this event firing in our actual game if this start stops working. So our tests are going to be really important that is validated and actually working. Otherwise, if they don't fire, since everything is relying on that event, everything will stop. And that's probably not what we want. So yeah, but theoretically that should work, and I think we're on the right C# version where that should actually just start working. And that's probably the easiest fix, and it's a pretty clean bit of code, so I kind of like that. Let's try running that again. Can't add script behavior because it's an editor. To attach a script, it needs to be outside the editor folder. What? No. Okay. So we may not be able to do that. We may not be able to create a MonoBehavior inside of the editor because we're in edit mode. I hadn't really thought of that. Well then. I don't think there's an easy way to switch this over to a runtime test. And I don't think... Do I want to? Do these work with edit mode tests? Maybe. Run? I don't know. I guess there's one way to find out. Let's... Two ways to find out. We could either... So there's two things. There's a... I'll copy it in, I guess. In here, we have this object called an MonoBehavior test. No, don't comment it out. Does it not exist? If it doesn't exist, we probably aren't going to actually use that. According to Unity, there's an MonoBehavior test, and that's all I know. And if you use this, it provides a testing method that effectively lets you tell when the MonoBehavior is done. I think we're just going to switch this over to a runtime test because I think that's the fastest way. We'll just create a play test. And so the way to do this, let's delete that. To create these new test things, you go into the test runner. This is the easiest way I've found, and click create play mode test assembly folder. If you want to do edit mode, I already have one, so we don't get that option, but you'll get a similar option for edit mode if you don't have one. And you can just click create this, and it will create a new folder for you, just like creating a new asset or something like that. And we'll do play tests. And so this is going to require similar configuration. Like here, we need to add our assembly again because that seemed to be really important. And then I guess we can just move this over there. Theoretically. And then it should recompile. Everything should be good. We don't have any edit tests anymore. We do have play mode tests. And so when I test this, what actually will happen is we have this init test scene large random number. When we run this, we should get an actual game object created in this scene because we're doing new game object. Then we should be able to attach our MonoBehavior to it and then actually use it. The problem with doing it this way, with doing run mode tests like this, is because we're creating game objects, we're going to be creating a state effectively. And I don't think it's going to get cleaned up at the end, which means there's going to be a bunch of game objects lying around. Part of the reason I have this feeling I'm not supposed to be doing this is because of that fact. Generally, you want your tests to be hermetic. You don't. What that means is you don't want your tests to be able to create something that influences other tests. And if we start creating a bunch of game objects, it's possible that instead of them running like by themselves, we might end up creating game objects that interact with other game objects, and the ones we're testing might be affected by some of that. And we don't want that. So, this isn't the best situation. And I'm kind of leaning towards I don't like this. But we will just keep pushing forward and see what happens. It's kind of an exploration here. So this didn't work this time. Object reference not set to an instance of an object. So that seems like a better error. At line 17. So what is line 17? One thing to note when I move those folders, we still had that old thing existing. It'll say deleted from disk in Visual Studio Code. If you save that, it will recreate that class for you. And you probably don't want that. So, all right, health.health, add component. So unless I'm mistaken, this should add the component and then return it. But I don't know if that actually happened. So let's try var health equals game object.get component of our health tracking component, just to separate those two features out. And this will let us see if we're having issues adding it or getting it back out. I think it's getting it back out, but I'm not sure. Reference not set to an instance of an object. Null pointer, it could just be that our game object was never created, that we couldn't create a game object in this state. Maybe that's what's happening. So we try to run it. I imagine we should get it, if we get it at line 17 again, like we did, that's probably super small. But if we get it at line 17, what that's kind of telling us is that we're getting a null reference here, probably the game object. Before I split that, it was the same thing. So let's undo this. Jumping to conclusions that don't make any sense. All right, so something's causing our game object not to exist. And I think That's why we have these MonoBehavior tests. MonoBehavior test. That still doesn't exist. Did I spell that? Oh, there's a U. Okay, cool. Change it. Awesome. That's fun. So, that's just a random type. We don't really care about that right there. But the idea here is you create a MonoBehavior that is that, and it creates an extra method. So if I actually create this and go into it, there's an isTestFinished, and this will tell if the test is finished. So if you want to run something over multiple frames, or there's some other condition that needs to be met in order for your test to complete, this will let you do that. So you can have tests that don't immediately stop. And that's kind of a nice thing. So what we're going to do is wrap our object, our health tracking component, in, let's scroll down, there we go, public health tracking testable component. I'm kind of making up this pattern as I go because I suspect it's probably not going to stick around. We can come up with something better. But this is sort of what I'm thinking. We're going to extend our health tracking component and implement the MonoBehavior test. And this should be a class. There. And so this means it's going to have all the characteristics of a health tracking component with that added feature of isTestFinished. And what we can do is just return true. Return true. We don't even need to return there. We can just say true. So our test is already finished when we start. Is that what I want? I don't know if that's what I want. Is test finished? Can I just make that a public property? And then just do get set. I think that works, right? Because the default Boolean will be false, so the test won't be finished. And then we can just say it's finished, and it will be finished. And then the getter will just always work. And what that lambda there was doing was just shorthanding the getter. So I think that should work. And then we can shorten this down into something that makes a little bit more sense. So I'm going to kind of copy from the Unity documentation. There'll be a link in the description because, yeah, I'm just not going to pull it up because it doesn't need to be. So they do coroutines because multiple frames, so the coroutine is part of that pattern. And then the idea here is you're going to yield, return a new MonoBehavior test like this, which is going to have the health tracking testable component like that. And return all that fun stuff. How does it, how does it know if it passed? So their example, oh, no, that doesn't make any sense. How does it know if it passes? Is test finished? In their case, just returns a Boolean. They have it counting frames, and after it gets above 10, it just returns true. So effectively, it runs for 10 frames and then returns true. But that isn't a testing. There's nothing being tested. There's no system. There's no test. I'm gonna guess. I guess. I don't know. This doesn't make any sense anymore. Okay. Huh. I genuinely have no idea how I'm supposed to actually write a test for this, because there's no, unless I'm missing something, there's no documentation here. Okay. Uh, I was so set that this was going to work that I don't think it is. They do use a Unity test. Maybe that's different. In order to skip frames when the test is running. Okay. Okay, I'm going to assume, and this might be a wild assumption, I'm going to assume that I need to do something like this and create our health, which is going to be equal to that. We're going to yield return our health like that. And theoretically, that causes it to skip frames until it's done. And so the idea here is something concurrent. The game is going to run while this yield return health is there until is test finished is true. And so what we want is to do our test here. So health.health equals 100. Health.isTestFinished equals true. Yield return health. That's a little bit weird. We probably don't actually need that. And then that? Question mark? Does not contain a definition of isTestFinished. MonoBehavior test.isTestFinished. That's because I want not the game object, the current. I think so. Yield instruction current. What? What is this? Component. That's what we want. The component. All right. It's the first time using this, so I'm making it up as I go, and that's probably not a great choice. So the component here is our thing. There's also a game object in here, which will be the game object that the component is attached to, I'm assuming. And then this health actually isn't the health. This is the stop. let's not do stop. I'm pressing the wrong key. I'm using the wrong hotkey. I'm using the IntelliJ hotkey. That's not gonna work. All right, MonoBehavior. There we go. So the MonoBehavior component.health. That's what we're testing. I don't know if that makes any sense. It doesn't really make sense to me. So we're gonna go with this, and I think this should work. And if it does, I have one other thing I want to test, which is to remove this is test finished entirely, because I don't think we need it. Which is a wild assumption because everything here is, but hopefully we get a green check mark, and we do. And it ran relatively quickly, 0.06 of a second. So pretty quick. Not super fast, but pretty quick. This yield return behavior is going to wait until some condition is met. The intention is to skip a certain number of things. So I think we can go back to test. The difference between a test and Unity test is a test is an immediate return and a Unity test is not. There's this yield return. We can take that out. And because we can take that out, we don't actually care about the is test finished either. And so our test just becomes create this mono behavior, set its health, and then assert it's true, which is actually shorter than when we were trying to manually instantiate that game object. And so hopefully this also works. And if this passes, then things make a little bit more sense, I guess. So if we run this again, we're either going to get a green check mark or that. And it's faster as well. 1/10 of a second. Why is there no reference exception now? What? Okay, there we go. I don't know why that was there, but it was. And so now it works, which means we can actually cut out a lot of this junk. And so that actually is not too bad. Now we just need to run and test the other two bits. And hopefully those go substantially faster. This should be a relatively quick and painless thing to do. So all we really want to do is do a component.start. And the way we're going to do this, I think, is with a send message. So I can say send message start, not JavaScript, start. There we go. And so this is just going to say invoke start on the MonoBehavior. They work a little bit weird in Unity. We could also, I suppose, make it public. That's another option. So just make a public start, and then we could just call it itself. But if you don't have that option, send message will just tell Unity to try to use some fancy magic to find a start method on the object and call it with extra parameters if you have those. But now that we've made it public, we can just call start. And so start, and what we're testing here is that our onHealth change is not null. And that is public, so hopefully this works. Not null is not null. I think is not null. I don't know which one we want, but we'll guess. And this should just accept one thing. So we're doing onHealth change is not null. Health. Let's see. Start of health tracker initializes health change event. One thing with tests is they can get kind of long. The names can get kind of long because the idea is to kind of imply whatever you're testing here. And in some cases that just gets a little bit verbose. Hopefully more so than your other code, and generally that's okay. If it's not, you can kind of cut it down, but it just, yeah. Let's try running this. Hopefully that passes as well. And it does. And I should, one kind of important thing when testing, just to make sure you're sort of not losing your mind, is to actually validate that it fails. And so my test should fail now that I've commented out this onHealth change, because we're not initializing it. If it's still passing, my test isn't good. It's not going to actually give me any signal if it isn't working. And then there's no real point other than to waste time in that test. But this one does fail. It says expected was not null, but it was null. So good. That means we're on the right track. So onHealth change, that's tested. This is tested. The only other thing we need to do is test this event. And so this might be a little bit more tricky because I don't really know how I'm going to do it. But we're gonna make it up, and that'll probably be all right. So let's see. Changing health value sends health change event. So we still need our MonoBehavior. We still need to start it because we actually need that event to be initialized. And then our eventual thing is going to be asserting that something happened. And so the way I've done this in the past, I don't know if this is going to work, but we're going to try it. Is was invoked is false. And we can use a lambda here and do MonoBehavior.component.onHealthChange equals our something. So we want to consume that event. So this onHealthChange is going to send us a float, I believe. So the health, like that. And so we'll get some health object out of that. And what we want to do is say was invoked equals true. And I think that works. Can't convert. Okay. We need to call a add listener function and then give it the delegate, right? Yeah. So let's wrap this like that. That's a little bit gross, but it works. And so we need to do this, and then we actually need to change the health and make sure it was working. So MonoBehavior component dot health equals something. We just need to change the value. And we could just like subtract something. I'm just going to set it to 100 again because our test already has 100, validating that 100 works and actually sets the value. So theoretically, this should work. If both of these are failing, we're kind of going to have an idea that maybe 100 was the wrong choice. It might require a little digging, but shouldn't be too bad. And hopefully, but its value is never read. So what we're assuming here is just that r was invoked and true. So we're assuming that something causes this was invoked to be true, which is going to happen when this happens. We can actually improve this a little bit. So invoked count equals 0. And we can set this to an int. And so the idea here is we are going to increment the invoked count every time we call this. And I should have just renamed it. But the idea is we want this to be equal to 1. And this means we'll catch things like sending too many events. So if we send 2 events every time the health is updated, we'll catch that with this test now. We wouldn't have previously. And so you can kind of modify things and kind of hopefully get some extra value out of that if you're careful. Otherwise, this can get a little bit tricky. But theoretically, we should have a 3rd event, and it should actually work. And there we go. So there's our event. If I run this, all 3 should pass. And they do. Cool. And that's actually fairly fast. All of them are running in less than like 0.05 of a second. This one is 1,000th of a second. So that's pretty good. So now that we have this, we've kind of got some reassurance that at least our health tracking component is working. The downside of all of this is I've now written 45 lines of code to test 38. That may or may not be good because it means that I can change this and know if things are still working. Some things more or less than others. One thing that we aren't testing right now is we are including the health with our health tracking component. When we send that event, we actually include the health. And so one thing that I can do is test that as well. And then we should be able to have pretty good coverage and actually know when this changes, did I break things? Because those are sort of the core things. We want to know what the health is, what the new health value is, and when was it changed, and things like that. And so making sure that those signals are correct is sort of what we want. So changing health values sends health change event with new health value. And so we don't care if it was invoked or not now. That's not what we're tracking in this. We have that test already, so we don't really need to keep iterating on that test. It just makes more work for us. So we're going to do last health count or value. So the last health value that we've seen. And the idea here is we are going to not do that. We are going to set the last health value equal to the health value that gets passed in that function. And so when we set the last health value in our event here, right here, I should expect that to be equal to 100. And so we should see 100 and not the previous health value. If we're seeing the previous health value, something is wrong. And so that'll be our 4th test. And then I just kind of want to demonstrate like a really benign looking refactoring that kind of triggers that specific test. And then we should be good. And I think that's kind of gotten to the point. These tests are actually not super bad. I was expecting like halfway through there, I was kind of expecting this to look really bad. It's not that bad. it's pretty much what I would expect. So I don't know. This might actually work for what we're doing. I was kind of leaning against it, but it might work. So one thing, now that we have all those passing, let's look at like refactoring this. Maybe I want to change the health after firing that event. They're both still going to be called, but because we're doing the health thing first, the health that's going to be sent is going to be the old health value, which means that new test we did should fail. Even though our health being set is going to pass, our event being fired is going to pass, our initialization is going to pass, that final one we just wrote should fail. And it should fail with something that we can actually address. We expected 0, but it was 100. I think I wrote my test backwards. Expected and actual? Do I have all of these backwards? Hold on. Expect 100. Expect 1. Yeah, okay. Just the new ones I had written were backwards. Sorry, it's between 2 days, and this pattern, like I was mentioning before, it messes with my mind. So, there we go. The last health value should be equal to 100. We got that failing. So we know that this change probably wasn't a good one, so we can undo that. And one of the cool things, these tests, according to Unity, can be run from the command line as well, which means you can integrate this into like a CI/CD pipeline if you're doing that. We'll probably end up setting one of those up for this project because it's going to be big. And ideally, I want you guys to be able to contribute to this. And it's just way easier to have other people contributing to your code if there's a remote way to validate things. So we might do that sooner rather than later. I don't really know what that looks like in Unity because I've never tried it. But we might make something up there. But hopefully this exploration of how testing works in this case was interesting, and we can kind of continue pushing forward with the Asteroids VR stuff. But if you have other suggestions or you've done testing in Unity and you think that you have a better approach or one that you think I should try, or just cautions or just new suggestions for things we should try, let me know in the comments. I'd love to hear them. Other than that, we have a Discord channel in the description. You're welcome to join that and come and chat with us. There's all sorts of fun conversations in there. People are showing off their really cool projects, asking some fun questions, and just kind of having a good time. So yeah, other than that, I'll see you in the next video. So until then, see you, Internet.